Hello again. So we've been working on the ball class, and we got it to where it's going all over the place. Look at that. We even have one that has a dx and a dy of 0. It's just staying in the same place. That'll happen once in a while. But so we have a whole bunch of balls. We've been able to create a whole bunch of balls, and they're bouncing off the walls and everything. But I just want to go back to, because we started out by looking at this this micro worlds example where our click handler for the turtles is this handle click. It goes forward 5, wait 1, and that's a forever. And then we have this touching handler. It says to handle touching, go right 180. And in the go button, we have everyone click on. So basically, we actually, you know what? I should have a button handler too. To handle go button. Let's say everyone click on. Just to be clean, and I want to have it. I want to use the ideas that we have in Python, where we write a procedure. We write in Python it's a function, right? And we register that function with the button or the whatever object is going to be using it. Okay, so now if I click on this, yeah, so if we click on this, then we saw that they bounce off each other, and so that's the kind of the behavior we want to get. Oh, one thing I wanted to point out though, let me stop this for a second. They are not really bouncing off the wall. It kind of looks like they're bouncing off the wall, but if we make them miss each other, you can see the way that turtles work in microworlds is that they wrap around the screen. So I think that's the first thing I'm going to change about the ball procedure, the ball classes. I want to make it wrap around instead of bounce, just to show you that you can have those as alternatives, because sometimes you're going to want one and sometimes you're going to want the other, right? So to do that, I'm going to do some refactoring again. We talked about refactoring the last time, because I want to save this behavior. I think this bouncing behavior is kind of interesting, and I might want to use it later. And also, it'll help me separate out better the bouncing behavior from the other stuff that's going on in this update. Because it's in the update, remember where we said, you know, if we're at left, then we're going to change the dx. Otherwise, if we're all the way over to the right, we're going to change the dx to -2 and so on. Okay? So what I'm going to do is I'm going to create another function here. Or actually, this is a method, right? This is a method in the ball class. So all these indented functions are actually methods that belong to the ball class. And I am going to define, let's say, bounce at edge. Okay. So when we get to, so this is the bouncing at the edge behavior. So remember, refactoring is when you rewrite the code, but you don't change the behavior. And the reason we do that is to make things clearer, so it'll be easier to make the change we want to make. So we want to change the behavior from bouncing at the edge to wrapping around at the edge. Okay? But the first step in that is to separate out that bouncing behavior. So this is all the stuff that makes bouncing happen, where we change the dy and the dx, right? So I'm going to cut that and put it under this new method. I'm going to paste it here. And now what I'll do is I'll call bounce at edge. So remember, we have to call that from the self object. So this is like kind of like when we use ask in Logo. You have to say what turtle you're asking. In Python, you even have to ask when it's the object itself. You have to be asking that particular object. So if I was asking some other object to do something, I could have some other name, and it would be that name dot bounce at edge. But I'm asking myself to bounce at edge, so I have to use this self parameter to say self bounce at edge. Okay, so now I should be doing exactly the same thing, because I'm calling this method, and this method does all the stuff that used to be right here. So far we should see no change. So let's just make sure we didn't break anything. Okay, still looks good. Alright, so now to make it easier to see that we're wrapping, what I'm going to do is I'm going to reduce the ball count to just 1. So we just have 1 ball. And make sure, okay, it's bouncing. So now what I want is I want that ball to wrap around. Okay, so if we want to wrap at the edge, let's think about what we need to do. So I'm going to define a new function over here. It's going to be wrap at edge self. Oops. And this is going to figure out what to do when we wrap at the edge. So let's see now. You remember we start off at 0, 0 up in the upper left corner of our picture, and I'm going to just say pass for now, because that means it doesn't do anything. Let's just see. Let's look at bouncing again. So we start at 0, 0 at this upper right hand corner, and x gets bigger this way and y gets bigger this way. So this is 0, 0. This is canvas width 0, right? Because our x goes from 0 to canvas width, and our y goes from 0 to canvas height. So this is 0, the position 0, comma, canvas height. Okay, and this is canvas height, canvas width. So when we hit this edge, our x is 0. When we hit this edge, our x is canvas width. And what we want is, when we hit this edge, we want to change our x from 0 to canvas width, right? Because we want the ball to stop going here and going here. Now, do we want it to change its direction? No, we want it to keep moving. If it's been moving from right to left and hits this screen, when it comes over here, we want it to keep going right to left. So it's always going to go right to left. So we're not changing the dx, we're only changing the x. Okay, so if we're at left, we only want to change the x. We want to say self x equals, so remember the left is where the left is where x is 0. So yeah, I have to write something in here, don't I? The left is where x is 0. So if I say canvas width, okay, that's all the way to the right of the screen, right? Canvas width is all the way to the right. What if I am, actually I could use elif here, couldn't I? Because if you're not at the, if you're at the left, you're not going to be at the right, right? So I could say if I'm at the left, else if I'm at the right. So if I'm not at the left, I could be at the right. But I'm not going to put elif here for the top, because what if I'm at the left and the top? But if I'm at the top if I'm not at the top, I could be at the bottom. So I'm going to do it like this. If at left, elif at right, if at top, elif at bottom. And I'll do the same kind of thing here. If elif self at right, self x. Now remember, we're still talking about the x because now we're over on the right hand side. Now we want to wrap around the other way to 0. Okay? So let's just see what that does. So far we're just wrapping on the left and the right edges. We're not doing anything about the top and the bottom. So if we disappear off the top, we're going to go away forever. Oh no, oh, I see. Wait. Oh yeah, I still have us bouncing at edge, don't I? I said bounce at edge. So I'm going to have to change this. If I want to see what the wrapping behavior is, I'm going to have to change this to that. Oops, let me be clear what I'm doing here. I'm saying copy and then paste. It's always better to copy and paste something if you can rather than retype it, rather than retype the same thing, because it saves, it reduces errors. So, oh, we just wrapped, yeah. But if we go off the top, we go on forever because we didn't change our behavior for that one. So we need to do the top and the bottom, right? So we need to do something like this, but we're just going to change the x and the y, right? So I'm going to copy this and paste it and then make the changes I need to make here. This is going to be y, and this is going to be y. And what I'm changing it to is, if I'm at the top is where y is equal to 0. So I want to go down to the bottom, and that's where y is equal to canvas height. And then if I'm at the bottom, I want to go set y to 0. So let's see if that works. Yeah, so now we're wrapping. Okay, so that's how you get wrapping to work, and then we'll on the next one we'll get started on getting these guys to figuring out how you figure out if they're touching each other. So then we can work out the getting them to bounce off each other.